All right. Today is day 4 for semester 2 of e-learning. It's going to be the Tuesday and Wednesday. Today you're going to be working on 3 things. You're going to be reviewing both probability, frequency tables, and percent. And then we're going to be introducing something that's actually relatively straightforward called the counting principle. These are going to hopefully be feeling pretty similar to what you've been doing in your algebra class. So first, let's review with a question about probability. Here is a bag with 10 marbles. What's the probability if we pick them at random that one will be gray? Take a second, see if you can answer. Alright, so remember, probability is the chance of the event that we want happening, which is picking a gray over the total chance. So here that will be the number of gray marbles over the total number of marbles, which of course, if you count, is 2 gray marbles out of 10. Simplifying that, we get a probability of 1/5, or if you're getting fancy, 20%. Alright. Another quick example of probability, same type of question, but now we're randomly spinning a spinner. So there's 10 equal-sized slices. What's the chance that we end up on a black slice? Take a second, see if you can figure it out. Now, interestingly, this question ends up yielding the same answer. Here we're taking the total number of black slices divided by the total number of slices, and just by coincidence it happens to be 2 black slices out of the total of 10. So again, taking 2 out of 10, or 1/5, will be our overall probability. Now you'll notice that the answer would change if we had, for example, gray or white as our option. There we would have 1, 2, 3, 4 gray out of 10, which is 2 out of 5. Or with white, same, 4 out of 10 or 2 out of 5 probability. Anyway, on to the next one. The next one is a frequency table problem. So each of 44 students was asked, do you prefer fiction books or non-fiction books? Here are the results. And among the girls, 9 chose fiction, 12 chose non-fiction. Among the boys, 8 chose fiction, 15 chose non-fiction. So take a second, see if you can answer correctly. All right, so we had girls that picked fiction, that was 9, and girls that picked nonfiction, that was 12. Similarly, we had boys that picked fiction, that was 8, and boys that picked nonfiction, that was 15. So for these types of questions, all you have to do is simply make the frequency table. Now the next type of question is where you're going to be given the frequency table, and your job will be to calculate a percentage. So this one says a movie club surveyed 200 high school students. The students were asked how often they go to the movies and whether they prefer action movies or dramas. The responses are summarized in the frequency table. So those that preferred action twice a month or less, that was 68 out of the total, and 3 times or more a month, that was 16. Those that preferred drama where twice a month or less, that was 64, and 3 times a month or more, that was 52. So what percentage of students go to the movies twice a month or less? So that's just the students in this column here. That includes both action and drama. So what we'll do is we'll add those 2 together and divide by the total to give the percentage. So that right here, twice a month or less, this is just this column. Adding those 2 together, 68 plus 64 gives 132. 132 divided by 200, that's 0.66 rounded off. Multiplying that by 100 gives us our answer, 66%. Now, the second question says, what percentage of the students prefer dramas? So that would be students in these 2 boxes. Okay, students that prefer drama, there's 64 that do it twice a month or less, and 52 that do it 3 times a month or more. So our answer there would be just add 64 and 52 and divide by the total. So like I said, this column is what we're interested in, and we have 52 plus 64 equals 116, and then we do 116 divided by 200, that's 0.58, or if you multiply by 100, that's 58%. All right. The next thing that we need to do is talk about the counting principle. You're going to have a bunch of questions just like this one. Okay. So next we'll discuss the counting principle, which is related to probability. basically we're trying to figure out how many different ways we could do a certain type of task. So in this example, it says Brian is ordering an ice cream dessert. He must order a size, a flavor of ice cream, and a topping. So there are 2 sizes, 2 flavors, and 2 toppings to choose from. How many different ice cream desserts could he order? Maybe you've been to a ice cream shop or someplace like that that says over 500 flavor combinations, and maybe you wondered how they figured it out. Well, actually it's pretty straightforward. All you have to do is multiply how many choices you have for each thing together, and that tells you the total number of choices. So for example, if we take the number of sizes that they have to choose from, 2, the 2 flavors they have to choose from, 2, and multiply them together by 2, that gives us 2 times 2 times 8, which is how many different ice cream desserts this person could have. To see that in possibly a slightly different way, the way this works is at the beginning, that person has 2 choices. They can either pick size 1, let's say medium, or size 2, large, for their flavor of ice cream. And then what happens is it splits off into these, what we call a tree diagram. So the person that picked, let's say, medium size, size 1, now has 2 choices of flavor, but so does the person that picked the large size, or size 2. They both get to pick either flavor 1 or flavor 2. So this person, if let's say they pick flavor 1, then they have 2 flavor toppings they can pick. So this is one possibility by the end. They picked this size, this flavor, and this topping. But of course they could have gone any way along this choice tree, or this tree diagram, sometimes they're called. And so by the end of all of this branching, that's why we call it a tree diagram, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8 choices, which is why we said our answer was 8. Essentially, you're just multiplying by how many choices are in each branch of the tree diagram. So let's do an example where there are different numbers of choices at each level. So for example, Peaceful Travel Agency offers vacation packages. Each vacation package includes a city, a month, and an airline. So you can pick from 3 cities, 2 months, or 2 airlines to choose from. How many different vacation packages do they offer? So in this case, all you're going to do, per the counting principle, is take 3 times 2 times 2, and that will give you the total number of choices. So 3 cities to choose from times 2, that's a total of 6, times 2 again is a total of 12. There are 12 different vacation packages that you could go on. Alright, so putting this into effect, we can have a question like this. Monroe Middle School is going to select a committee. The committee will have a faculty member, a male student, a female student, and a parent. So there are 4 categories that we're choosing from. Here are the positions and the people interested in each. So right here, you have Mrs. Baker and Dr. King. You have Brian, Raphael, and Milan. Those are the male students. And then you have Mary, Jessica, and LaShonda. Those are the female students. You've got 3 parents, Mrs. Murphy, Mrs. Brown, and Mr. Brown and Mrs. Hill. And based on the list, how many ways are there to fill in the 4 committee positions? So all we need to do is know how many categories we have and multiply by the numbers. So you can see here we've got, in terms of faculty members, we've got 2 members, Miss Baker or Dr. King. We've got 3 students, Brian, Raphael, or Milan. Those are the male students. The female students, there are, again, 3 of those. And parent, there are 3 of those. So remember, all we do is multiply the number of choices together. That would be 2 times 3 times 3 times 3. 2 times 3, that's 6. Times 3 is 18. Times 3, again, that's 54 choices that we have. Let's double check that we had that right. And we did. So again, 2 faculty members, 3 male students, 3 female students, 3 parents, and we multiply them all together, we get 54. Based on the simple counting principle, take a look at this next question. Okay. From that last question, you can see here that you just take the total number in each category and multiply them together. So you have here 2 faculty members, 1, 2, 3, 4, 5 male students, 1, 2, 3, 4, 5 female students, 3 parents, 1, 2, 3, 4 school board members. So you simply multiply all of those together to tell how many different ways there are to fill the committee positions. So there are 2 times 5 times 5 times 3 times 4, which happens to be 600 different ways you could fill up this 5-person committee. So there you have a couple of new things, especially the counting principle. Even though questions like this can look a little bit complicated, we're really just taking some numbers and multiplying them together to figure out the total number of possibilities. Hopefully that's helpful. See you guys later.